As developers, we're kind of wired to think in absolutes, right? If this, then that. But this new wave of agentic AI, it's forcing us to throw that deterministic playbook out the window. And that leads to this really fascinating idea. What if the best blueprint for this new kind of intelligence isn't in some computer science textbook, but it's actually right inside our own heads?
All right, let's really break this down. Over on the left, that's our home turf. That's our comfort zone, right? Predictable, logical, if A, then B. It just works, we trust it. But then you look over on the right, and that's where things get, well, a little wild. Agentic AI doesn't live in a world of certainties. It operates in a world of probabilities, which, when you think about it, is a lot like the messy, complex web of neurons firing away in our own brains.
Yeah, and this quote just nails it. It's the first time our software is starting to look like our wetware. We're not just writing lines of code anymore. We're actually building systems that kind of mirror the brain's own processing hierarchy. So, how on earth does this actually work? Let's peel back the layers, and we're going to start with the very first step, perception.
Okay, first up, perception. This is all about how we and, our AI counterparts actually see the world. And spoiler alert, it is not as simple as just snapping a picture. It's this super active process of pulling out what actually matters from this ocean of raw data.
And that brings us to this key concept, transduction. See, your retina isn't just some passive camera sensor. No way. It's a seriously sophisticated piece of biological machinery that takes light, actual photons, and converts it into the electrical language of the brain. The really crazy part? It's already processing the signal before it even leaves your eye.
And this table just lays out the parallel perfectly. I mean, look at this. The biological system, it takes in photons and spits out electrical spikes. The AI system, it takes in RGB pixel values and spits out a multidimensional tensor. But if you look closer, they're doing the exact same thing. They're both wrestling with messy, real-world data and trying to turn it into something structured and useful.
So here's the big takeaway, the real developer insight. The end goal here is identical. It's all about feature extraction. That very first layer of your visual cortex, the V1, it's literally hardwired to find things like edges, lines, and contrasts. And guess what? That is the exact same job that a kernel in a convolutional neural network is programmed to do. It's like we reverse engineered our own biology and didn't even realize it for a while. How cool is that?
All right, let's build on that. Let's move to our second mechanism. So we've got a signal. Now what? How does it actually travel? The answer here reveals this incredibly deep and honestly surprising connection between a neuron's synapse and an AI's weight.
We usually think of connections as being binary, right? Either they're on or they're off. But in the brain, it's so much more subtle. A synapse is really more like a probability gate. A neuron can fire, but there's absolutely no guarantee that the signal is going to make it across the gap. It's all governed by something called release probability. The connection itself is stochastic. It's uncertain by design.
And that uncertainty, it forces us to ask a really fundamental question. What if the whole goal of computation isn't to find one single perfect deterministic answer every single time? What if instead the goal is to just explore a whole landscape of possible good answers?
And boom, that brings us right into the world of large language models. Because the brain's release probability has a direct one-to-one analog in the AI world, the temperature setting. If you set the temperature low, you get predictable, kind of boring, deterministic answers. But crank that temperature up, you're embracing the probability. And that's where you get creativity, novelty, and surprise.
So here's the big insight for us developers. We're not actually asking the model for the one right answer. What we're really doing is asking it to take a sample from this enormous, cloudy distribution of plausible answers. And that's the magic. That's what allows an LLM to write a poem 1 minute, then spit out some Python code, and then tell you a joke. It's exploring possibilities, not just looking up facts in a database.
Okay, so our agent can see the world, and it can think in probabilities. Awesome. But what about memory? This is a huge one. For our third mechanism, let's dive into how the brain's hippocampus and an AI's vector database are basically solving the exact same problem in these remarkably similar ways. Here's something wild. Your brain does not record your experiences like a video camera. I mean, can you imagine? That would take an absolutely impossible amount of energy. Instead, it does something neuroscientists call recursive summarization. It brilliantly pulls out the essential meaning, the core gist, and just tosses all the noisy, irrelevant details. It's just an incredibly efficient compression system.
And this is where the parallel is just stunning.
The hippocampus in our biological system, its job is to store the gist. And for an AI, well, retrieval augmented generation, or RAG, when you pair it with a vector database, it does basically the same thing. It doesn't need to keep every single word in its active memory. It just goes and retrieves the most relevant piece of context it needs for whatever it's doing right now.
So the big takeaway here for developers is that the future isn't just about building these ridiculously massive million-token context windows. No, it's about building smarter systems. The agent starts to act more like a skilled librarian, intelligently searching through its own history to find the exact piece of information it needs, right when it needs it. It's so much more efficient, it's scalable, and hey, it's all biologically inspired.
All right, this is it. This is where it all comes together. We've talked about perception, we've talked about signaling, and we've talked about memory. Now let's put all those pieces together into the thing that truly defines an AI agent, the agentic action loop.
And this quote just says it all, doesn't it? A brain without a body is just a processor. An agent without tools is just an LLM. I mean, the intelligence we've been describing is totally useless if it's just stuck in a vacuum. A brain needs a body to actually do stuff in the world, and an agentic AI needs tools, APIs, functions, access to systems to turn its brilliant plans into actual actions.
And here is that loop in action. It's a four-step dance. Step 1, perception. The agent looks around and observes its environment. Step 2, decision-making. It uses that probabilistic brain we talked about to come up with a plan. Step 3, autonomous action. This is key. It uses its tools, its API hands, to actually execute that plan. And then, finally, maybe the most critical part of all, Step 4, learning. It looks at the result of its action and self-corrects for the next time around. It's a continuous cycle of improvement.
So, what's the big picture here? Where is all of this heading? Well, it really points to a fundamental shift in what it even means to be a developer. We're moving into a future that is way more neuromorphic, or brain-inspired, than ever before.
Seriously, let this one sink in for a second. For decades, our entire job has been to build deterministic tools that do exactly what we tell them to do. But now we're starting to architect autonomous entities that can perceive, decide, and act all on their own. Our role is shifting from just being a coder to being a creator, an architect of these intelligent systems.
And that leaves us with one last big question to chew on. As we keep pushing the boundaries of what AI can do, maybe, just maybe, the most fertile ground for the next big breakthrough isn't in faster GPUs or even bigger models. Maybe it's in a deeper understanding of that incredibly efficient 20-watt masterpiece we all have sitting right behind our own eyes. What else can we learn from it? What's the next secret it's going to reveal?